Hi guys, this is Dr. Gonzalez. This is calculating an ANOVA using Jamovi. An ANOVA. Apologize for that. I've also apologized for this being a tad bit late. I have been struggling with a migraine for the last day. So with that, let's get started. Let's go over a short review of how we look at ANOVA and what it basically means before we go straight into Jamovi. So in the last lecture, we covered ANOVA. I'm not going to say ANOVA again, but we talked about the different kinds. So remember, ANOVA stands for an analysis of variance. It goes beyond a simple t-test because it lets us compare more than two levels of our independent variable. So for example, we talked about different types of therapy. We had one example of a one-way ANOVA looking at cognitive behavioral therapy versus mindfulness versus a control group, and then looking at a dependent variable such as an anxiety score on the GAD-7. So an ANOVA is going to also let us statistically design many different kinds of tests that are important in experimental design. We have one-way, two-way, three-way, and we can also do anything between subjects and within subjects. Remember, you also have mixed measures from that. So the end goal of an ANOVA is to produce the F ratio, which is based on variance instead of a mean difference. Mean difference is going to be your T test that we did. You've got your obtained difference between sample means over the difference between that you're expecting by chance. Our statistic that we're talking about this time is here, and that is the variance between sample means divided by the variance expected by chance. So instead of differences in means, we're looking at the variance between means. You're going to see that F ratio calculated out. It's going to be significant when it's large, based on the numerator being large, the variance between sample means, when divided by variance expected by chance. When that's small, we end up getting this right here. So that correlates to a rejection of our null hypothesis because there is a significant difference due to at least one mean being an outlier, and your distribution is also narrow. Remember, we would follow that up with post-hoc tests to find out where exactly that difference is at. We would fail to reject if the means, the variance produces a similar ratio from the numerator and denominator, and then we would also fail if our three distributions are so close together that you can't separate what comes from one group or the other. So we walked through last time a simple one-way independent measures ANOVA. So we had I'm going to do another one this time, and it's a little different scenario. We're going to talk about, does the format of lecture delivery affect the quality of students' note-taking? So this is like a real-world situation. We know that taking notes generally by hand, the literature shows that when you take notes by hand, you're more likely to retain that information. So we're expecting students to take notes by hand in this particular experiment here, but the format of the lecture delivery is going to be different. So they're going to be taking notes by hand in three different scenarios. So we talked about this just a little bit in the last slide. You've got your independent variable, which is going to be the format of our lecture, and there are three levels, three conditions. You can either be live in person, you can be synchronous via a live Zoom lecture, or you can use a pre-recorded video lecture, very similar to this course. I hope that you're taking notes by hand or doing something, because it definitely will help you retain the knowledge better, at least in my opinion. Now, granted, that could change as generations of new students come through. My son, for example, has been in school for 11 years. He's an 11th grader, and I've noticed in the last few years that he doesn't tend to come home with notebooks full of notes anymore. But he does pull up his iPad at school and takes notes in like a Word document. So that might be a totally another different study we could look at is the difference in retained knowledge. Is there a difference between taking notes by hand versus taking notes via an electronic device? But anyway, our dependent variable here is going to be the quality of the notes that have been taken. And what we would do when we would design this is we would come up with a rating system that uses a rubric, and then we're going to have graders that would grade those notes, and those graders would be blind to each condition. And I am sure in this day and age of AI, there is a way to even train AI to do this so that it is even more standardized between between each set of notes. All right. So the design for this is a one-way independent measures ANOVA, because each participant is only going to be in one type of lecture. We're not doing repeated measures where the students would be in each condition in different times. So for our hypotheses in this situation, we have our null that says mean, sample mean 1 and 2 and 3, they're all the same. So there's no differences in note taking across the lecture formats. And our alternative hypothesis is going to say at least one of those formats produces different note-taking quality scores that are significant. And we're going to use an alpha level of p equals 0.05. So next we would calculate our F ratio. So you can go in and download the PDF in Canvas of the source table, and you would fill it in. And what I actually did was just to show you here, I'm including this right here, which is from where I ran this analysis in Jamovi. And this gives us the sum of squares, which is it's a little bit easier to do. All of these things are easier to do in Jamovi, bottom line, or in SPSS or JASP or whatever you would choose to use. But for you to see conceptually the between and within and all of that, you could probably pull out this PDF and print it out, or just pull it up and use it on your computer or whatever you wish to do. So if you filled in your data from that table, using the lecture format, which is right here, lecture format, and sums of squares, that's right here, the sums of squares, and the MS, mean of squares, which is also here, right here, you would use the residuals for within groups, okay? So we had between groups and within groups in the chart. So in pulling this data out of SPSS, Jamovi, I wanted you to know that residuals correlate to that between groups, okay? So we would pull the 2 for our degrees of freedom for lecture format. That 2 right there, the 72 comes from the residuals of degrees of freedom. Sums of squares, we pulled this down for 64.1. I actually did this by hand, so there is a little discrepancy, you can see sometimes, with the rounding, and then 66.1. And we can calculate out our mean square, which gives you that right there, and this right here. And we calculate from that an F ratio of 252.2. So Jamovi is going to tell you whether or not that is significant, but for the purposes of understanding conceptually and how we used to have to do this by hand, on the next page I'm going to show you what our decision rule would be. So you have an F table that should also be in Canvas, and to find the critical values of that F ratio, we're going to need to know the degrees of freedom between and within, okay? Remember, you've got your numerator, and then over here it would have been, this is degrees of freedom denominator, okay? And this would be degrees of freedom numerator over here. I had to trim the table for it to be able to sit. So what do you do if your F table doesn't have the exact number for the degrees of freedom? You're going to round, and in this case, since 72 is less than 75, we would round down and we would use 70. That's going to be right here, okay? And so what we're going to get is a critical value, which is going to be this 3.13 right here, okay? And I apologize for having to chop that up because you do see two things here. One of those is for one particular alpha level, the other's for a different one. But in this case right here, we're going to reject our null if our F ratio is greater than 3.13. And I do believe it was. So yeah, our F ratio was 252.1. So we're going to reject the null based on our ratio being that output of the ratio being greater than our critical value of 3.13. Please remember, that's based on a critical value. When you base that on a p-value, that's how you would figure this out, using a statistical output without having to drag out one of those tables. Honestly, as a practicing statistician in certain aspects of my careers, I never really recall having out an F table. Looking at critical value. Thankfully, with the use of statistical programs like Jamovi and SPSS and whatever, there's a lot of steps in the old school calculations that you don't really have to do anymore. So it's important to understand conceptually what's happening behind the scenes of Jamovi. All right, so we need to do some post hoc tests now to determine which groups are different. We just know at this point in time between those three groups: recorded lectures, synchronous Zoom lectures, and in-person lectures, somewhere there's at least one difference. So what we would do, we're not going to go over how you would do post hoc tests by hand. There's simply not enough time. I did run a Tukey's post hoc test using note-taking score. All right, that was the only variable in that database anyway. But what happens is all of our pairwise differences were statistically significant. So there's more than one significant difference here. So if you look at the output, I have live versus recorded, and then I also have Zoom in here as well. And you see Zoom doesn't have anything down here because we can do all of the comparisons are actually up here. So you have live versus live, and obviously there's nothing there, right? So now I'm going to compare live to, let me get a different color here. We're going to do live versus, I'll just erase it. That'll work. Bam, I'll get that up too. So now we're going to look at live versus recorded. And what we come up with is there is a t-value of negative 15.7. The mean difference, which that would be the difference in the quality scores, the mean difference of the quality scores between one group and another. And you can see it's starred too. You have your degrees of freedom, and then you have your p-value. And remember, I just told you a minute ago that p-value means that's where you would find your significance here. So if I go look at those three asterisks right there and go down to the bottom, that means this is significant at the p is less than 0.001. So that's where that all comes together right there. So bottom line, live versus recorded, there is a difference between the quality of those notes. Okay. And you look over here, recorded note lectures resulted in the highest quality notes, followed by live, then by Zoom. So when you're looking at live versus recorded, recorded was the best but we're comparing live to that right there, okay? So anyway, that's the first part. Let's check the other combinations. So we had live versus Zoom, okay? So this would be I'm taking notes by hand, and I'm taking notes using Zoom. So this is live synchronous, but using Zoom. So here I have a mean difference of 1.63 with a p-value that is also significant. So what does that mean? That means that when the students took notes live versus on Zoom, the live notes resulted in a higher quality of note. Now, our last one that we need to compare is going to be in the second part of this chart right here. We need to get one more comparison. We're looking at recorded notes or recorded instruction with Zoom. Okay, so here I see that my difference is 5.90. It is starred. The value of the p-value is less than 0.001. So that means there's a significant difference between the recorded notes and the Zoom notes. And if you'll notice something right here, you see recorded versus Zoom gives you 5.90. Recorded versus live gives me a negative. This is for the mean differences, okay? And then live versus Zoom gives me a positive right there. So what that tells me is that my students took better notes when watching recorded lectures when compared to live versus Zoom sessions, okay? That's where that negative part comes in right there. Now, interesting, keeping with this, it says, however, students also took significantly higher quality notes live when compared to Zoom, okay? Zoom lectures consistently led to the lowest note-taking quality. So you've got to go through and interpret these very carefully because you can rank this, right? I've got two here that when compared to Zoom, synchronous Zoom classes, both the live and the recorded lectures produced higher quality. So I can put these in a rank order. What's the best time to take notes? The best kind of note, or best condition to get the highest quality notes? First, it's recorded, pre-recorded lectures, followed by in-person lectures, followed by synchronous live Zoom sessions. So that's a lot, right? So how would you write this up in APA style? Well, the first thing you do is you have to report the significance about the ANOVA itself. So we would say a one-way ANOVA was conducted to examine the effect of lecture format. That was our independent variable with 3 different conditions, and then our dependent variable was note-taking scores. And what we do is we report in the next sentence, we report our significance of the F ratio. So the results revealed a significant effect of lecture format with an F of 2 and 72 are our degrees of freedom. We report the F statistic and we report the significance. And what we do is we kind of give a statement at the end summarizing this in non-numerical language. So the type of lecture delivery significantly influenced students' note-taking quality. You could also change that and say the type of lecture delivery significantly influenced the note-taking quality from students, whatever. Then you would follow up with a paragraph telling you about the post hoc tests because I need to know where those differences were, right? So a Tukey post hoc test was performed. Participants in the recorded lecture scored significantly higher on the note-taking measure, and we report the mean difference. So the mean difference was 4.27. We did Tukey's is a form of a t-test, right? So t of 72 is negative 15.70. We give the significance level. And we compare it to something because it's mean difference. Then those in the live lecture condition. And we also say similarly, the recorded lecture group outperformed the Zoom lecture group. and we report the mean difference, the T, the degrees of freedom, and the significance. And then we can also say, in addition, students in the live lecture condition had significantly higher scores than those in the Zoom. So we throw that in there too. So bottom line, you can see the differences between those groups. My thought process behind this was that the next thing you would do is we want to examine why. Why are they different? And you don't do that through statistics here, but you would follow up with some other studies, looking at some reason why the group that had access to recorded lectures did so much better. And my thought process when designing this example was perhaps the recorded lectures allowed students to pause and reflect as they're writing, and even to open up things like AI, like open up Chat GPT and tell them, hey, what would the teacher said this, bam, without losing their place in the lecture itself. And I also acknowledge, perhaps maybe the live notes also performed better than the recorded Zoom notes, because I'm not the recorded Zoom, the live Zoom. In person, you can ask clarifying questions, and you can't necessarily do that when you're dealing with a video. So I apologize. This is what you got right here, but I'm always available if you have a question. So let's go ahead and start getting ready to look at look at Jamovi to see about how this would work. So go ahead and download the instruction and notes quality data set. Okay, so if you've got your instruction and notes quality ANOVA data set up, we will get ready to go through this. If you actually look into the data set and scroll down and look, it is a little different than you've seen in the past. I didn't put a participant ID in it this time, but it's really just the lecture format and the notes taking. So here is the table presenting the results from the post hoc tests. So make sure I have the right highlighter here. So this is what you saw in the earlier slide here, but it's giving you a table that shows you all possible comparisons between groups. It also, because you hit descriptives and all of those fun things I told you to click, it shows me the mean differences between conditions. So I can, using this in conjunction with that other table from the ANOVA, you can see in which direction you're going with these comparisons, these mean differences here. Okay. And this also gives you the other things that you need for your APA write-up. Okay, so I know on the last slide I showed you guys just how to do it with some screenshots. So this time I'm going to actually take you through Jamovi with the screen recording. So you're going to go to analyses. I've opened up my data, and if you wanted to see what that looked like over here, you can see I've lecture format. There's 3 levels of it. It's a nominal variable because all I'm doing is using it as a grouping variable in the ANOVA. And then I have note-taking score. It's a continuous variable. It's that rating based on those blinded coders that would assess the quality. So go to analyses, and then under ANOVA, select one-way ANOVA. Okay. And we're going to move lecture format to our grouping variable and note-taking score to our dependent variable. And we want to assume equal. Notice if I left them both, you're going to see there's a little bit of difference between these two because you're assuming equal variances when you use the Fishers. So right now I'm going to uncheck that, but I want to come back to that in a few minutes and show you some stuff. We're going to leave that alone. Additional statistics, we're going to run our descriptives. We might even tell it to give us some descriptive plots. There's only going to be one, but you can see, you can visualize which one had the highest mean, the recorded, followed by live, followed by Zoom. And when we did Tukey's, we still found out even this was significant, that comparison between those two. So anyway, we're going to also go ahead and tell it to do our post hoc test. We are going to use Tukey because we assumed equal variances. Sorry, we're also going to include test results, and we're going to tell it to flag our significant comparisons. And that's where we get our beautiful table that we already interpreted in the previous slide. So right now, though, I'm gonna tell this to go back to none and to remove these. I want to emphasize here. We have variance, and you see where it says assume equal. Well, remember when I told you to go back and look at the standard deviations? They're all pretty similar, which is really good. That's why I would tell my ANOVA calculating software to assume equal variances, but they often build in a check. So there's a test here, an assumption check for a homogeneity of variance. This is a Levine's homogeneity variance test. And you will see right here that we get a score and with degrees of freedom, and we get a p-value of 0.957. So that is a large p-value when compared to our acceptable level of what is significant and what is not. So that's why we assume equal variances, because if you run this homogeneity of variance test, it tells me my variances are homogeneous. They're similar enough that I don't need to worry about doing something else. And I don't have a database handy, a data set handy to pull up and show you what it would do when that test is violated, or when you would need to go in and tell it to do a Welch's. But I do want to go over one more thing. You see where this says one-way ANOVA, and it's got variance and it's got Welch's and Fishers. So I don't know if you noticed when you went up here to analyses earlier, under ANOVA, I have one-way ANOVA and then I have ANOVA. So how do you know which one is different? Well, it's in this particular case, it doesn't matter. So if I go to ANOVA, but you will see there's a whole lot more things I can do in this one. But anyway, I'm going to move lecture format to my fixed factors, which is the same as that grouping variable we did the other day on the other one. And then note-taking scores, I'm going to move it over right here. And the first thing I get is the same thing that I got up here. Okay? It's just in a little bit different format, right? And I can calculate effect size in this. I can also tell it models that's different, assumption checks I can check for that homogeneity, like I just showed you. I can do some contrasts. I can also do my post hoc tests. I can do other ones that I might want to do. So I can move lecture format over here and tell it to do Tukey. There you go. It's the same thing I did up at the top. I can also give it estimated marginal means, depending on if that's something that you need. And I can also tell it to save residuals. So my point in showing you this was that if you accidentally went into ANOVA instead of one-way ANOVA, you're still going to get the same thing as long as you know what to check. Okay? All right, so the next thing that I want to show you, we're going to kick it up a notch, is a two-way independent measures ANOVA. And this one is the research question: does the type of new pet and home size influence anxiety levels in new pet owners? All right, so here's my thought process behind this one. Some people have suggested that having a pet might help you reducing your anxiety. I know there's nothing I like better than snuggling up on the couch when it's cold in the winter and letting my little cat here, one of these little crazy cats, come sit next to me and sleep. That's very warm. I can imagine that would reduce anxiety. But other people might actually say that the sheer notion of having to share their space with a new pet might cause them anxiety. Okay. Think about a parent that their kid's been asking them for a long time to have a dog. And so you get a dog, and then the parent ends up being the one that has to care for it because the child doesn't realize the responsibility of having a pet. But anyway, on top of that, imagine having a pet in a small space, a really tiny space that you're not really, you know, don't have enough room for maybe even the people that are living with you. So this is one of the examples that I gave you in our discussion about the different kinds of ANOVAs. So now I'm going to walk you through how you would do this. This is a 3x3 factorial two-way independent measures ANOVA. And our research question is going to be, does the type of new pet and home size influence anxiety levels in new pet owners? There is a data set for this in Canvas if you want to pull it out and walk through it. I will do just like I did for the previous one and do a screen recording of it when we're done. So let's get started with it. So our design is a two-way independent measures ANOVA. It's 3x3 factorial. Our independent variable number 1 is going to be the type of pet. And we have dog, cats, and ferrets in this example. And our second independent variable is going to be the home size. So we have small, which is less than 800 feet, medium, which is 800 to 1600 square feet, and large, which would be anything greater than 1600 square feet. And that is a very quantifiable measurement that I gave instead of going, well, how many bedrooms? Okay. I live in a 1,200 square foot home with three bedrooms, but I previously shared a almost 1,000-foot home with 3 bedrooms. All three of them are much smaller. So you get what I'm saying? I'm trying to, depends on lots of variables. So I wanted to give it square footage instead of number of rooms. Anyway, our dependent variable that we were looking at is anxiety. And we would, in this fictional data set here, we use the GAD-7 with a total score range of 0 to 21. And the bottom line is the higher the score, the higher the anxiety. So we're looking at two things in this particular, well, actually three. We're going to have our hypotheses with our main effects, and then later on we might have an interaction to test, okay? But our hypothesis right now is going to be, there's one set of hypotheses for each one of our independent variables. So the first is a null and an alternative for pet type. So there's either a difference. Oh, I'm sorry. Let me back that up. I put all the nulls together and all the alternatives here. So we have two null hypotheses. One says there's no difference in anxiety based on pet type, and the other null says there's no difference based on the home size. And then the alternatives are that, yes, there is a significant increase in anxiety, and here there's a significant increase in anxiety based on home size. Okay. So I mentioned on the previous slide, we would have a hypothesis also for something called interaction. So an interaction is a occurrence where the effect of one independent variable depends on the level of another independent variable. So for example, the effect of pet size on anxiety might change depending on the size of the home. For example, a new ferret owner, ferret as a new pet, they may feel more stress, but only if the ferret is in a small home. Okay. So we want to see if there is any sort of interaction between pet type and home size. So it's going to look at all three levels of both of those independent variables. But we have the one hypothesis. So how do you calculate this in Jamovi? Well, you're going to open up your data set. So if you downloaded that earlier, go download it from Canvas. It is titled, I believe, Pet and Anxiety. I know it starts with pet, but anyway, it's in Canvas. I just put it in there. Go to analyses, and this time you're going to go to ANOVA, that second one that I showed in the video previously. And then you're going to pick ANOVA, not the one way. Go to the second one. What I want you to do is move anxiety to your dependent variable, and then move both pet type and home size into those fixed factors. And under model fit, I want you to make sure that overall model test is picked. Now you can look at the results here. So I have an overall model, okay? And that's important because I wanted you to see that you need to put that there to be able to tell if there's any differences here. If not, it's just going to go down into this right here. That's pet type, home size, and then your interaction. So what we see is that we have an F of 44.9. It is significant. And then looking underneath here, I have a significant pet type. I don't know what pet type yet. And that is significant at that P is less than 0.001 level. So you've got to ask yourself the question altogether, do our predictors explain a significant amount of variance in anxiety? And the answer is yes, because for that overall model, an F of 8 and 171 for our degrees of freedom produces an F value of 44.901 at P is less than 0.001. That is significant. So something's going on here. What do you do next? So we're going to look at the differences in factors, okay? So pet type is significant, and I just pointed that out on the other side. The type of pet has a significant effect on anxiety. Home size was not significant. You can see that the p-value for home size was 0.878. That is greater than 0.005, so it is not significant. And then you can look at the pet type and home size interaction. So we found no interaction effect here. The type of pet, the effect of the type of pet on anxiety did not depend on home size. So what would you do next? Well, next you would do your post hoc test. So let's look at that. So now you could scroll down, or you could have told it to do this beforehand. It's up to you. But in Jamovi, you would scroll down to those post hoc tests. You would move over pet type. The reason why we're only moving pet type over is because it was the only thing that was significant. Make sure that you've got Tukey selected, and it's going to run. It's going to run this analysis and produce these results down here. So you can see cats compared to dogs, not significant. Cat compared to ferret, significant. Dog compared to ferret, significant. So like we said, I didn't do an APA write-up for this one, just because I know that I wanted to get this to you guys fast. You've got one example in there, so it should be sufficient. But again, if you look at the results, the difference between cats and dogs wasn't significant, but cats and ferrets, yes, and dogs and ferrets, yes. So interpreting this in plain language, overall ferret owners experienced more anxiety than cat or dog owners, and it was regardless of the home size, because we did not find an interaction. So your assignment, let's go over those so you'll be ready to go. All right, guys, let's go over the first of your two assignments that you have this week. The first one is the ANOVA assignment number 1, and it's a Word document. It's going to look like this. And in this particular scenario, you are working as a sleep researcher with a child psychologist, and you'll have just finished a huge study, collecting a lot of data, looking at adolescence and sleep quality. So you're going to read each question in this file, and then answer them here and paste the appropriate different outputs in the appropriate places. So the first question has to do with experimental design. I want you to read this section here, and then underneath this, answer the question about the independent variable, the dependent variables, and whether or not this is an experiment. Okay. Then for the remainder, you're going to need the data set. So let me open this up in Jamovi so you can see what I'm referring to. So you're going to download that data set, and then you're going to open it. It is titled the Adolescent Sleep Study Data. And it's got a lot of different variables in here. Some of the ones that you need for the descriptives question are going to be at the end. So let's look at that. In the second one, you're going to run some descriptive statistics for these particular variables here. Pay attention to what statistics it's asking you to make sure you've got selected. You're going to paste your screenshot and write your answer there. Then I want you to generate a frequency table for these two variables because they're categorical. And you're going to paste their screenshot and answer the questions there. The next question, question 3, has to do with it's a one-way ANOVA, and they want you to run a one-way ANOVA on whether or not there are significant differences in sleep duration across the 3 conditions of the independent variable. Follow the directions, answer the questions. Question 4, same thing, but it's asking you to change the variables up that you're using. You're going to keep the conditions the same, but you're going to look at the validated sleep quality score. And then the last question, we're going to change it up just a little bit. I want you to run a paired samples t-test, and the instructions for that are down here. But pay attention to this here. It's going to tell you what specific things you need to make sure are checked. You're going to paste your screenshot and write your answers in the appropriate places. And that's pretty much it. And then you upload it under the correct part, and then there will be one other assignment in there for ANOVA that I'm finishing at the moment. So in about half an hour, everything should be in there, and you should be good to go.